Hi everybody, today we're going to be talking about propositional operators within truth functions. And so when we think of propositional logic, what we've been working on so far, we're talking about complex propositions a lot of the times, where we have these simple propositions that are put together in order to make complex propositions. And the truth and falsity of those complex propositions are predicated on the truth function of the elementary propositions. So basically, the complex proposition is going to be true or false based on how the simple propositions relate to one another. And so, for instance, we might think of the truth of a simple proposition P and simple proposition Q as a function of the truth of P and the truth of Q independently. So if truth of P and Q depend on whether or not P is true and whether or not Q is true. So if we know that P is true and we know that Q is true, we know that P and Q are true. And so this is going to be important for us for a couple of reasons. First, it's going to be helpful when it comes to determining whether or not arguments are going to be valid. We're going to be able to kind of cut through the content of propositions and break down the propositions to its bare bones, to the structure, and then we'll be able to put that structure through a truth table where we can determine whether or not the argument as a whole is going to be valid or invalid. And so we can simplify propositions, we can simplify arguments by creating variables that stand in for simple propositions, and then we can connect those simple propositions together using the 5 symbols that we're going to talk about in this lecture. And so all of our assertions when it comes to propositional logic can be broken down using 5 symbols in order to connect simple propositions. Now, it's important that we know that not all propositions, not all complex propositions are truth functions of their component simple propositions. Sometimes we'll have simple or we'll have complex propositions that really don't depend necessarily on the truth and falsity of each simple proposition within it. So for instance, John believes that Mary loves Peter is not going to be true or false based on any sort of connective that's going to connect the 2 simple propositions within this together. Now, this isn't really important. You're not going to need to necessarily know this, but I just want to draw your attention to the idea that this doesn't necessarily work for every single complex proposition, just most of the propositions that we use in our daily lives when we make assertions and connect to these simple propositions using connectives like ands or ors or conditional statements, and we'll talk about them more. So breaking complex propositions down into the connectives that connect simple propositions are 5 operators, 5 symbols that are represented using the symbols that I have here. Now it's important to note that these symbols are going to be different depending on different material that you read. So in one instance, you might look at a book and, for instance, the arrow pointing to the right can sometimes be symbolized as a greater than sign. In other instances, it can be symbolized in a sideways horseshoe. Sometimes the double arrow will be symbolized with an equal sign, or will be symbolized with a triple bar, indicating that what is left and what is right of this symbol is equivalent, essentially. You might also see that the ampersand sign is represented with a dot, the multiplication dot that you might see in math textbooks. And so these symbols that I'm using are convenient for computers. They're convenient for plugging this material into your computer, so doing the homeworks and whatnot, putting things into Microsoft Word. But just know that there are other ways to write these symbols, and any of those are acceptable. So if you find it easier to write the horseshoe, sideways horseshoe for a conditional statement, then use that. If you find it easier to use the equal sign feel free to use that. But our complex propositions are going to be broken down into the simple propositions that are going to utilize these 5 connectives. And we'll go over all 5 connectives together. But as an example, let's look at the statement that Mary and John went to the store. Now, Mary and John went to the store is a complex proposition. It is complex because it connects 2 simple propositions, Mary went to the store and John went to the store. So with these 2 simple propositions, we can combine them into a complex proposition using the ampersand conjunctive symbol. So if we were to view Mary went to the store as M, and we were to view John went to the store as J, we could represent the entire complex proposition as M and percent J. So I can read this bottom equation by saying Mary and John went to the store, noting that this is a complex proposition made up of the 2 simple propositions, Mary went to the store, John went to the store. And so here are the 5 different connectives and what type of connectives they are and the symbols that we're going to be using. So last week we talked about conditional statements. We talked about necessary and sufficient conditioning. And you may remember in the PowerPoint that I made the equivalence of certain complex propositions using the arrow. So the P arrow Q. When we see P arrow Q, we're essentially being shown a conditional complex proposition where P is the antecedent and Q is the consequent. So when we see P arrow Q, we will read that if P then Q. And remember, a lot of times conditional statements might not always have the words if then in them. However, we need to make sure that we're knowing what is necessary, what is sufficient, and then we can write them within this symbol form, P arrow Q. Now, if we're looking at a conditional statement, but rather than the antecedent being sufficient for the consequent and the consequent being necessary for the antecedent, that both are necessary and sufficient of one another, then we would get a biconditional. And biconditionals are typically expressed with if and only if claims. So if I were to say P if and only if Q, I would write this P double-sided arrow Q, or again, P equal sign Q. These are equivalent because what we're saying here is that P is both necessary and sufficient for Q, and Q is necessary and sufficient for P. The next symbol that we're going to look at is the disjunction symbol. And the disjunction symbol is typically expressed using the word or. And this is symbolized with a V. So if you'll see here, the complex proposition of PVQ would read P or Q. So we could say Mary went to the store or John went to the store. Now, on the other side of a disjunction is a conjunction. Instead of breaking up 2 things, we are bringing 2 things together. We bring things together using the word and, a conjunction. But we also use a lot of other words in English, such as but. And so when we're conjoining things, when we're creating a conjunction as a complex proposition, we represent this with an ampersand, or the multiplication dot. So here, P and Q, we can say Mary went to the store and John went to the store. This would be symbolized as P and Q. Lastly is the negation, or the tilde. And this symbol is the squiggly line that would go in front of any letter and would represent a negation of whatever that letter was. So if P in this instance referred to Peter went to the store, negation P would be Peter did not go to the store, or it's not the case that Peter went to the store. So with these 5 symbols, we can break down arguments, we can break down paragraphs of information into symbols and letters, where each letter represents a simple proposition, and then a letter with a symbol and another letter, or a symbol, a letter with the negation symbol, will represent a complex proposition. All of our sentences, for the most part, all of our complex sentences that we're going to be expressing that are propositions are going to be these simple or complex propositions where we can express them either using a single letter or multiple letters and these symbol connectives. And this will help us determine whether or not certain complex propositions are true. For instance, when I'm looking at this top P arrow Q, in order for me to know whether or not the statement, if P then Q, is true, I would need to first know the truth of P, and then I would need to know the truth of Q. And depending on the truth of those two simple propositions, I will then know the truth of the complex propositions. And before we start to think to ourselves, well, if all of the aspects are true, that's good, like that's what we're aiming for. For instance, in line 2, the biconditional, if P is true and Q is true, then P double-sided arrow Q is true. While that may be the case, we'll also discover that if in this instance of P if and only if Q, if P is false, and Q is false, then this biconditional statement is actually true. And so there are going to be different combinations that we look at next week where we'll discover that these different combinations of simple propositions conjoined together to make a complex proposition will make that complex proposition true or false depending on the relationship between the simple and complex, the simple propositions. For right now, however, it's simply just important to memorize these 5 symbols and the way in which we use them. So we use them with conditional statements, we use them with biconditional statements, disjunction statements, conjunction statements, and negation statements. And most of all of our propositional logic, most of all of our propositions and assertions that we make, most of our arguments that we make are going to be using propositions that can be conjoined using these 5 symbols. So almost anything can be broken down using these 5 symbols. We just have to sometimes reword it, just like we would reword necessary and sufficient conditions that don't utilize the words if and then to use the words if and then. Here we can also reword things to utilize disjunctions or conjunctions and so forth. This is all for the aim of trying to determine whether or not our arguments are going to be valid or invalid, so that when we look at a paragraph of written word, we can strip out all of the content and see whether or not the premises will relate to each other in the right way, that they will infer the conclusion. Remember, the goal is to create valid arguments, good structured arguments where the premises lead to the conclusion. In order to determine whether or not the premises lead to the conclusion, we need to know whether or not the complex propositions or premises are going to be true in themselves, because remember, we want true premises to lead to a true conclusion, and so we would need to know whether all of the internal simplified elements of the simple propositions will create true complex propositions, and whether those true complex propositions will lead us to a definite conclusion. So, doing a little bit of exercise here, if I were to give you the complex proposition, if it rains or snows tomorrow, we won't go to Topsham or play cricket. The goal would be to symbolize this, breaking each section up into as many simple propositions as we can break it up, and then connect those simple propositions using one of the 5 connectors or one of the 5 symbols that we just learned. So the first thing to do here is identify how many simple propositions we have within this sentence. And within this sentence, we have 4 simple propositions. The 4 simple propositions are: it rains tomorrow, it snows tomorrow, we go to Topsham, and we play cricket. Remember, each one of these is a proposition in its own right. Each one of these expresses a claim that could be true or false. So it could be the case that it rains tomorrow, or it could not be the case that it rains tomorrow. It could be true that it snows tomorrow, or it could not be true that it snows tomorrow, and so on and so forth. So now that we know that we have 4 simple propositions, the goal is to connect these 4 simple propositions to one another using just the variables and the connective symbols from earlier. So here we might see that the sentence begins with an if-then statement, and therefore we know that there's going to be an arrow, there's going to be a conditional in here. In addition, we see the word or, so it signifies a disjunction, and then we see another or that will signify another disjunction. So if we were to write this out in symbolic form, we would get the equation of P, if P or Q, then not S or R. So here we would read this as: if it rains or snows, then we won't go to Topsham or play cricket. The tilde signifies the won't, or it's not the case that. And notice that we break these sections into parentheses. And just like in math, we want to make sure that we're grouping these together so that we know what is going to happen when and where. If we weren't having parentheses within this entire equation, it wouldn't be clear that we're talking about if it rains tomorrow or snows tomorrow, then we won't go to Topsham or play cricket. We might think of it as: if it rains tomorrow, or, and then single out snows tomorrow, and the snowing bit is what will then lead us to the consequence of we won't go to Topsham or play cricket. And so this, just like working on your multiplication tables, is going to be something that requires practice. We're going to have to just look at sentences and symbolize them over and over and over and over again until we really start to understand how we symbolize arguments and get good at it. And so let's look at another. If I don't drink both wine and spirits tonight, I won't get the desired effect. Again, the first thing you want to do is determine how many simple propositions there are. And then once you determine how many simple propositions there are, then we can assign a variable to them and then put those variables into an equation using the 5 symbols. So here we have 3 simple propositions. I drink wine tonight, I drink spirits tonight, I get the desired effect. Again, we know there's a conditional statement, so we're going to have an arrow somewhere. We see the word won't and don't, so we know we're going to have negation symbols. We see the word and, so we know there's going to be an and% somewhere. And so when we write this all together, we would get: it's not the case that P and Q, or if it's not the case that P and Q, then not R. So again, looking at this equation on the bottom, we would read this in English just like the sentence on the top. If I don't drink both wine and spirits tonight, I won't get the desired effect. Notice how we're saying if I don't drink both wine and spirits, and we're grouping wine and spirits together, and we have the tilde on the outside of the parentheses. If it was inside the parentheses in front of the P, then we would only be talking about not P, but we would be talking about the positive Q. So it's very important where the negation goes, just like with math, if the negation sign comes outside of the parentheses or if it comes inside the parentheses. Here again, we can see another example. The Chargers will win the Super Bowl if they get rid of Phillip Rivers. Two simple propositions, and this being a straightforward if-then claim, we see that Phillip Rivers is attached to the if, so we would actually have that be the antecedent. So if Phillip Rivers leads the Chargers as our antecedent, we would read this Q arrow P. Here we have another, either the Democrats win the next election or I'm going to leave the country. Now, this is a tricky one because we're using an either or statement, and an either or statement is different than just an or statement. Or it's important rather to think of an either or in terms of an exclusive either or, where it has to be one or the other, and if it is one, it can't be the other, and if it is the other, it can't be one. Or if it's an instance when we use the term or, where it can be both. Because as you'll see in the next lecture, the truth of a complex proposition that's a disjunction can be true even when both parts of the disjunction are true. But when we use an either or, where it's exclusive, meaning that when one happens, the other doesn't, or one doesn't, if the other happens, then one doesn't, we would write it a bit differently, and we would write it using the biconditional double arrow. And then we would negate one of the sides. This would mean that when Q happens, P can't happen. And we could also write it that if Q doesn't happen, then P does happen. Essentially, these have to be opposites. So we know that when one happens, the other doesn't, and if the other happens, then this one doesn't. We wouldn't necessarily write this even though we have an or statement with the V, because the V is going to symbolize an and or statement rather than an either or statement. So it's going to be very important moving forward that when you see the words either or, it's important for us to think about whether or not the sentence is talking about an exclusive either or it can be an inclusive either or, because this is going to make a big difference. So I might say, right, you can have chicken or fish for dinner tonight. But what I mean when I say that, if I'm using the V symbol, is that you can have chicken, you can have fish, or you can have chicken and fish together. But if I were to say, you could have chicken if and only if you don't have fish, what I'm saying there is the exclusive. If you have one, you cannot have the other. If you have the other, you cannot have the one. And so we need to just think to ourselves what the statement is saying before symbolizing them. And so either ors can be quite tricky. And so when we're symbolizing, we usually use P and Q just as the typical symbols. It's okay for you to use any letters, any variables that you want, as long as you create a key for whatever those symbols represent. But we're typically going to use P and Q, and when you read most texts, it uses P and Q. So P or Q, where the or is an exclusive either or, just like we were saying, is symbolized with that double-sided arrow, not necessarily the V, even though we're using that disjunctive word or. Now, when it comes to symbolizing arguments, we're doing the same exact thing, but we're doing it for each of the propositions, even the conclusion. So if this is my argument, if it's lunch, then the gong will have sounded. The gong hasn't sounded, therefore it's not lunch. I'm trying to conclude, trying to prove to you that it's not lunch. And how am I doing that? By providing the premises that if it's lunch, then the gong will have sounded, and the gong has not sounded. So again, I will go through the entire argument and identify all of the simple propositions. Once I've identified all of the simple propositions, I will create variables for those. Here, there are only two simple propositions just used over again. And so the two simple propositions being used is it's lunch and the gong has sounded. Now that I have the simple propositions laid out, I can then rewrite this argument in standard form using those simple propositions, but combining them when necessary with the connectives, with the symbols, in order to create the complex propositions. And so this argument will look like this when it's symbolized. So here we are able to see the bare bones and scaffolding of this argument without the content getting in the way. We can see that we're trying to conclude that not P, and we're trying to conclude not P by assuming that if P then Q and not Q, therefore not P. So we will be able to later take this symbolic argument, put it into a truth table, and then that truth table, when it's filled out, will tell us whether or not the argument is valid or invalid. And so we have a verifiable way of determining whether or not arguments are valid or invalid. We don't have to think about possible worlds. We don't have to think about whether or not we can come up with an idea of the conclusion being false even though the premises are true. Instead of racking our brain, we can just create a truth table and it will tell us whether or not the argument is valid or invalid. Here again, we have a little longer, a little more complex argument, but we would do the same exact things. Determine how many simple propositions there are and what propositions there are, and then create a key to symbolize each one of those simple propositions, and then rewrite the argument using the symbols and the variables from the key. So here we would have 4 simple propositions. There is a resurrection of the dead, Christ rose, our preaching is in vain, and your faith is in vain. And now using these 4 variables, we will rewrite the argument. We are simply just placing in the letters for that simple proposition and then adding the connectives in order to create those complex propositions. So here, our argument in symbolic form will look like this. It looks complicated, but really, once you have those variables, those simple propositions written down, you're simply just plugging them in and then assigning the symbols based on whether or not it's a conditional, a biconditional, a disjunction, a conjunction, or the negation. And so we're just doing this with all of the propositions for arguments in order to determine, in order to see and verify whether or not arguments are valid and invalid. And so it's very helpful to practice turning propositions into their symbolic form.